Hello everybody and welcome back to another video of Funland Tutorials. So in today's video we will be continuing with our topic from previous week, and we will be talking about vector. Now today we'll be looking at different types of vectors and we'll be looking at their definitions. So before we go into that, let us first define something called the magnitude of a vector. So what is essentially the magnitude of a vector? Now last episode we talked about vectors being something that has both magnitude and direction. Direction is essentially something that keeps or that puts apart a vector from any other scalar quantity, as I have written here. Scalars are quantities which have no direction but they have just a magnitude, whereas vectors are quantities which have both a magnitude as well as a direction. Now the fact is, direction is something that has been represented by this arrow over here. As I mentioned before, the vector initiates at this point, which is called the terminal point, and it moves in this direction. But then what about the magnitude, right? Essentially, when we talk about the magnitude of a vector, we essentially think of how big the force is, or how heavy a body is in terms of its weight. Essentially, we are talking about its magnitude, which we call modulus of a vector. So essentially, let me just write that down. By magnitude, we talk about the modulus of a vector. Modulus of a vector. Now, how do we represent that? Modulus of a vector, or modulus in general, essentially in mathematics, modulus is represented by keeping the variable in between two vertical straight lines like such. So essentially, if I am talking about V, sorry, let me just write that down properly. If we talk about V and I put an arrow above it, this is essentially what I'm talking about, the magnitude or the modulus of a vector. What essentially does it say? This essentially says how large the vector is. So if I'm talking about a force of say F units, this modulus will be equal to F. So it's essentially says how large the force is. You can also think of it as sort of an imaginary way of thinking how long this line is, because in a lot of cases when we draw a longer line, we think of vectors which have a higher magnitude, and when we draw shorter lines, we think of magnitudes which are, at least in comparison to this earlier vector, shorter or smaller in magnitude or in modulus form. That is basically the modulus of the magnitude of a vector. Now let us first think of different types of vectors. So we have something called the null vector or the zero vector. So we have the null vector or the zero vector. What is this null vector or zero vector? Essentially, these are vectors which have zero magnitude. So to define null vector or zero vector, we think of it this way. Any vector, suppose I think of V as the vector, if I have the magnitude or the modulus of that vector as 0, then we call it a null vector. Here null essentially means 0, and of course the zero vector. Now what are the peculiarities of this vector? Essentially, this vector, since it's 0, it can also be represented by zero vector as such. That is essentially writing down the zero vector mathematically. The peculiar thing about zero vector is that since it's 0, essentially the force, the vector did not move essentially. If I think of the example that I gave in my previous video, if this is my laptop screen and it's being pushed by someone who's standing here from this direction to this direction, so that person is pushing it from my left side to my right side, then essentially there's a movement of the laptop screen, right? Like if it's not very heavy, I can expect that the laptop screen will move. But if I'm thinking of a zero or null vector, then the laptop screen will not move, which means the initial point is as if coinciding with the terminal point. So that is a peculiarity of the null vector or the zero vector. The terminal point and the initial point coincide with each other. Besides, since it essentially it boils down to one single point, essentially the null vector or the zero vector boils down to one single point. If a point does not have a direction, right? If you draw a straight line, you can think of it, oh, is it collinear with this line? Is it collinear with this line? You can think of it in that way. But if it's just a point will be collinear with any line segment, that you can think of. This point is lying on this line, it's lying on this line. Rather, look at this way. It's lying on this line, it's lying on this line. It can lie on infinite number of straight lines, right? So null vectors and zero vectors, essentially you can either think of it as they do not have a direction, or you can think of it that they are collinear with any other vector, say a vector, any other a vector. So that is the peculiarity of a null vector. It's not exactly a unit vector, but it's sort of like a very basic vector. It's like 0 in basic mathematics. Then you have something called a unit vector. So the unit vector is sort of like the unit component in vector algebra. So you have a unit vector. The special thing about unit vector is, as the name suggests, the magnitude of the unit vector is 1. So if I think of mathematically representing it, I would say modulus of the vector v. So if I'm talking about the vector v again, modulus of the vector v is equal to 1. That defines my unit vector. That is called the unit vector. Now there are very specific vectors which are unit vectors, of course, because their magnitude needs to be 1, that is their modulus needs to be 1, but you can find out the unit vector of any vector. What do I mean by that? Suppose you have a vector like this. So this is a vector that I'm talking about. This is its initial point, and say this is another vector, a vector, since I am talking about v a lot of the times here, and this is its terminal point. This is the direction in which the vector is moving. Now how do I essentially find out a unit vector that corresponds to this vector a vector? Let me just change the color. So if I again consider the fact that modulus essentially is a way of representing how long this line is, let me think of it this way. This is the entire length of this vector is essentially modulus a units, right? If I think of putting a scale over here, think of how do you measure the length of a line. You have a line, and then you divide it into segments by how many. Suppose this is a 5 centimeter. Suppose this is a 5 centimeter length. So you have this line segment starting from A to B, and then you divide it into 5 equal parts. If you divide it into 5 equal parts, what you get? You have 5 centimeter, and then you divide it into 5 equal parts, which means each part will be of 1 centimeter. That is your unit. So you have the entire line segment and you divide it by 5. Why do you divide it by 5? Because you want to break it into 5 equal pieces. So that is sort of like the length of the line, that is the how long the line is. We use a similar, not exactly same, but a similar approach we can use basically to find out the unit vector. Here the unit quantity is 1, and here we want to find the unit vector. So here we divided the line, the length of the line, by the number of parts in which I want to break it, or the essentially the length. This is the line, sort of like, it's a rough comparison, but this is sort of the line. 5 centimeter is the length of the line, and 5 is the magnitude, how long is it. So if I think of it this way, my vector is a dashed. So this is my vector. This is sort of like corresponding to the numerator of 5 centimeter, and I want to divide it by how long is the vector. How long is just modulus of a prime, modulus of a vector. This quantity is the unit vector corresponding to this vector. So this red vector that I have corresponding to this unit vector, we have this is the unit vector corresponding to a vector, unit vector. So essentially, what is a unit vector? Unit vector is a vector divided by its modulus. So unit vector is equal to vector divided by its modulus. So that is the unit vector. That is how we define a unit vector in for any vector given in any direction. This vector could have been in any direction, and the expression would have been the same. What are equal vectors? Equal vectors are two vectors. So let me just write that down first. What are equal vectors? Equal vectors. Equal vectors are essentially two vectors, of course 2 or more vectors, rather 2 or more. So let me just write 2 plus vectors, which again, vectors have two quantities that need to be checked. Vector quantities have quantity, magnitude as well as direction. So equal vectors means they need to have the same magnitude. So they need to have the same magnitude equal, and they also need to have same direction. So same direction and same magnitude, that is when we say that two vectors are equal. How do we think of it? If suppose I have a vector like this, so this is my terminal point and this is my initial point and this is my terminal point. And suppose I have another vector which is the same length. Suppose this is the same length. So this is an equal vector. So it starts from from here and it ends here. Now if it had been somewhere here, then my initial point would have been here and my terminal point would have been here. But you see, the direction is the same. This is also moving in this direction, this is also moving in this direction. Magnitude is also same. They do not lie on the same straight line, and they are not parallel, or they are not one just beside each other, but they have same magnitude and same direction. So these two vectors qualify as equal vectors, right? So these two are equal vectors. Similarly, we can have something called a negative vector. In case of a negative vector, the thing is, let me delete this part. In case of a negative vector, essentially the quantity is same, so the magnitude is same, but the direction is opposite. See, this vector is moving in this direction and this vector is moving in this direction. So we say that this vector is the negative of this vector and vice versa. So we can also say that this vector is the negative of this vector. Essentially, in terms of negative vectors, so we discussed both equal vectors and negative vectors. So let me just write negative vectors. Now, another thing about negative vectors or equal vectors is, if you have like vectors, what are like vectors? And we'll also be talking about unlike vectors. So let me just write that down as well. Like vectors are vectors which move in the same direction. So they did not have same magnitude. A vector moving in this direction, another vector moving in this direction. So this, they are all moving in the same direction. They are all like vectors. But this vector and this vector and this vector, these two are like. But this and this vector is moving in this direction, this vector is moving in this direction. So this vector and this vector, they are unlike vectors because they are not moving in the same direction. This and this vector is also unlike. This vector and this vector is also unlike because they are not moving in the same direction. So like this, we can have equal vectors, negative vectors, like vectors and unlike vectors. There are also a couple more type of vectors which we'll be discussing in the next episode.